Hi everyone, in this screencast today we're going to talk about the depletion of the ozone layer and how CFCs affect the formation and destruction of ozone. So to start off, we're going to talk about what ozone is. So ozone is what we call an allotrope of oxygen gas, O2. So different versions of the same element, O3 versus O2. Ozone is made naturally in the atmosphere, typically up in the stratosphere where we would find most of it. But also down in the troposphere at the level that we're existing in, that ozone can be made by photocopiers, laser printers, high voltage electrical wires, all sorts of things. So in the atmosphere, ozone is continually formed from oxygen gas. So we get molecules of O2. A molecule of O2 splits by absorption of high energy UV to form oxygen radicals, which is an oxygen with an unpaired electron. This oxygen radical can then attach itself onto an oxygen gas molecule to form ozone, like this. So they pair up, and in doing so that we form O3 molecules. So you can see the chemical equations representing this process over on the right. So notice that the oxygen radical doesn't appear in the final equation because it's formed in the first step and then used up in the second. So overall, we've turned 3 oxygen gas molecules into 2 lots of ozone. This process is happening continually in the atmosphere. Likewise, we also have ozone molecules being destroyed in the atmosphere. What happens? Different wavelengths of high energy UV are absorbed by the ozone molecules, splitting them apart, forming oxygen radicals and oxygen gas, O2. The oxygen radicals can pair up with one another to reform another O2 molecule. So as before, the oxygen radical doesn't appear in the final equation, but you can see overall we've turned 2 ozones into 3 oxygen gas molecules, the reverse of the previous process. Now the idea is that this process happens continually, over and over again, switching between oxygen gas and ozone, but in both processes we've absorbed high energy UV. So this can show you the overall cycle. The absorption of the first wavelength of UV, forming the radicals, attaching to oxygen gas molecules to form ozone, and by absorption of different high energy UV, it can split apart again to reform oxygen gas and those oxygen radicals pairing up again. So this process is happening all the time. It's a very natural part of the process, but the great thing is that in both stages, harmful UV has been absorbed. And what we'll see now is how CFCs can interrupt that process. So a CFC stands for chlorofluorocarbon. So it's a molecule that contains only chlorine, fluorine, and carbon atoms. Okay. So in the past, CFCs have been used as refrigerants in use in air conditioning, in your refrigerator, all manner of things that need to cool them down. It can be used to create the bubbles in expanded polystyrene, what we call styrofoam, if we need to create an atmosphere or an environment with inert gas, and also as a propellant in aerosols like hairspray and you name it. Okay? But now the reality is that CFCs are banned in Australia. They're no longer allowed to be used, and we'll talk about why. So in the past, initially, scientists were really enthusiastic about CFCs. They were really, really useful. They're very unreactive. They don't catch on fire. They're generally not harmful to human tissue. And so they started to be used in everything. They were better replacements for what used to be there. The problem was that they eventually discovered that they deplete the ozone, damage the ozone layer, and they saw that there was a link to the presence of CFCs. So the evidence started to accumulate. And then over time, scientists and the rest of the community accepted that CFCs are something that should be banned. And so there was a process of phasing out to where we are now. So let's talk about how CFCs actually do this process. So what happens is that one of the chlorine atoms in the CFC molecule can break off to form what we call a chlorine radical. So the CFC absorbs high energy UV radiation, breaking one of those covalent bonds to leave a chlorine radical, like in that sort of an equation you see there. So that unpaired electron. The problem is that this chlorine radical is very effective at destroying ozone. So the chlorine radical, which we show with that dot, interacts with an ozone molecule. Breaking it up, we form oxygen gas, O2, and then this ClO radical in this process. What happens then is this ClO radical can interact with one of the many oxygen radicals in the atmosphere, reforming oxygen gas, but regenerating the chlorine radical so that it's there and it's able to do this process once again. So the 2 reactions that we've just seen, where we've got the chlorine radical damaging ozone and then being reformed. So if we connect these together and we simplify it, that you can see if we take out all of the things that are present on both the left and the right, that we end up with an equation that does not have the presence of the chlorine radical in it, because it's formed and then used up and regenerated. Okay, so it removes ozone by turning it back into oxygen gas. There's no absorption of UV light in this process, which is what's particularly bad. The chlorine radical regenerates. It can last for a very long time, 30 years or more. There's lots of chlorine radicals in the atmosphere now from when the CFCs were first being used, and it means it also can react with a large number of ozone molecules, 1,000 plus, 10,000, name, any number you like. So looking at this ozone cycle, so you can see when the oxygen radical is formed by splitting up an oxygen gas molecule, we formed ozone, one of which is interacting with the chlorine radical, one which isn't. The one that reacts with the chlorine radical, we start this destruction process, the one that doesn't. So we're absorbing some UV, but we're continually regenerating the chlorine radical, so less harmful UV has been absorbed by this ozone layer. And then that becomes a problem. It's the reason that we slip, slop, slap in summer, because we get increased levels of UV, which can lead to lots of medical problems. Increased risk of sunburn, accelerated aging of skin, lots of skin cancer, some incredibly serious, and also increased risk of cataracts. All right, thanks very much for watching.